So for this lecture, we're going to look all about lipids, and this is chapter 5, and then also we're going to include the supplement B that's after that. That is about lipids and health and look at heart disease and all of that. So let's talk about what lipids are. So we typically maybe say the word just fats in general, so this all fits in this group, so we'll talk about some definitions of that to start with. So lipids are water-insoluble compounds, meaning that they do not mix with water well, and I'll show you what that looks like. And they are made up of carbon, hydrogen, and some oxygen. They do provide 9 calories per gram, so they're much more calorically dense per gram than our protein and carbohydrates. If you remember, those provide 4 calories per gram. We can get our lipids from plant or animal sources, and we'll talk a little bit more about our sources of fat really do make a bigger difference in our overall health outcome than just the total amount of fat that we consume. So we'll talk about that as well. So we have 4 major classes of lipids. So fatty acids, which are a major source of energy, triglycerides, which is the most abundant source of fat in both our diet and how we store fat in our bodies. So we'll talk about that. Sterols, which cholesterol is a good example of a sterol, and then phospholipids, which phospholipids make up a lot of our lipid membranes, our cell membranes, so our lipid bilayer that we may hear it called in our cells. So we'll look at those in more detail. So what do lipids do? So they are very important for that cell membrane. So like I mentioned, you have those phospholipids. You also have cholesterol and other things that make up part of that. They are important for the transport of fat-soluble nutrients. They cushion, protect, insulate our organs. It's a concentrated source of energy in our diet. And even from a food perspective, it contributes to texture, flavor, when we look at it from food science and why we want to eat foods with fat in it. And it can help increase our satiety. It can help slow gastric emptying, so delaying how quickly our body absorbs the nutrients from a meal, all of that. So let's first talk about the different kinds of fatty acids. So a fatty acid is just a chain of carbon atoms. It's got hydrogen attached to it, a carboxyl group on one end, and a methyl group on the other end. And I'll show you what that looks like in a picture here in a minute. This is the primary component of triglycerides and phospholipids both. And we talk about fatty acids in 2 ways. Chain length, and you can see that here, so short chain, medium chain, and long chain fatty acids. And then what you probably hear them talked about more is the degree of saturation. So saturated fat, unsaturated, trans fat. So we'll look at those. So saturated fats contains no double bonds and contains a maximum amount of hydrogen. So no more hydrogens can fit in, therefore it's saturated with hydrogens. These tend to be more solid at room temperature, so more like a butter or lard. And then unsaturated fatty acids have at least 1 double bond, so therefore they have less than the maximum amount of hydrogen. So theoretically, it's unsaturated with hydrogen. You could add another hydrogen or more than 1 other hydrogen into that. And when we look at mono unsaturated, that just means 1. So 1 double bond in there. And then polyunsaturated fatty acids have 2 or more double bonds. These tend to be more liquid at room temperature, like our olive oil, other vegetable oils, that kind of thing. And then trans fats is just the way the hydrogen atoms are arranged. So it's on opposite sides of the double bond. This makes it a little bit more solid, and so it's a little bit more maybe stable at room temperature, and so that's why they'll put it in some foods. But you know, we've learned that trans fats have a similar effect on our health as saturated fat. So hopefully this visual gives you a little bit more information of what we just talked about. So the first one is saturated fatty acid. You can see the methyl groups at the end. They're green just for this visual, and then the carboxylic acid group, which is blue, just to show you what those look like. But you can see with saturated fatty acid, each carbon has 4 bonds. There's no room for more hydrogens to be added in there. There's no double bonds. The double bond in the carboxylic acid group doesn't count when we're talking about these. So there's no double bonds in there as well. You can see that they sit more flat, and so they're more able to be packed in, so they're more solid at room temperature. So you can see some sources, cheese, butter, lard, the fat in a lot of our meats, coconut, those kind of things are more saturated fat. And then our monounsaturated fat has at least 1 double bond there, and so you can see in that one that you could theoretically put 2 hydrogens in there. It does kink a little bit with unsaturated fatty acids, therefore it doesn't pack as tightly together. And then the sources, olive oil, nuts, avocado, olives, those kind of things are sources of monounsaturated fatty acids. And then our polyunsaturated fatty acids, this one just has more than one double bond, so this example they're showing you has 2. It's even a little bit more kinked. One thing I want to point out is what they're showing you here in the, get the mouse over there. So these are actually triglycerides. So this part is the fatty acid, and there are different chain lengths. You can see even on some of them, there are different degrees of saturation. So this one has saturated and then 2 monounsaturated. And so that's just an example of what it's really like. So it's not that every single triglyceride has the same 3 fatty acids attached to it. There can be variety in that. So this is just showing you that a little bit here. With the polyunsaturated, you can see some different oils and other things that have that. So let's look at cis versus trans now. So our normal, or maybe not normal, the way it normally occurs in nature, there are some naturally occurring trans fats in nature, but most of our unsaturated fats have the hydrogens on the same side of the double bond. So you can see here, same side of double bond, same side of double bond, same side of double bond. So we consider that a cis arrangement. When they're on the opposite side of the double bond, like here, that's considered a trans arrangement. And so that makes it sit a little bit more flat. And so you can see there are some naturally occurring trans fats in dairy and beef, but most of our trans fats have come during the manufacturing process, so hydrogenation. And so those trans fats are thought to not be as good for us. And you can see margarine was a really big original source of trans fats in our diets. So this chart looks at the sources of saturated fat in the US diet, and so a lot of our mixed dishes like burgers, sandwiches, pizzas, etc. contribute the most of that saturated fat to our diet, followed by snacks and sweets, dairy, protein foods, and then you can see some other ones down there. So just something to think about, where we find saturated fat in our diet in the US. So back to that triglyceride that I showed you. So we talked about that when we looked at the different types of fatty acids. So this is another example. It's 3 fatty acids and a glycerol molecule. So this, again, is the major source of lipids in our food. It's the major source of how we store fat in our body. It does provide energy. It carries our fat-soluble vitamins. So it is the biggest contributor to our lipids in both our diet and our body. So I wanted to look a little bit at fatty foods, since we just talked about the triglycerides and how they don't all have the same fatty acid attached to it, right? It's not like one triglyceride has 3 of the exact same fatty acids. There's a mixture. And so even our foods that we think of, maybe really high in saturated fat, like butter. Butter is not 100% saturated fat. It's a mixture of saturated fat, monounsaturated, and polyunsaturated. And so this chart just shows you the combination of that. Walnuts, for example, are 10% saturated fat, 14% monounsaturated, and 76% polyunsaturated fat. And so you can see just the difference on those. The tops are highest in the polyunsaturated, the middle group are highest in the monounsaturated, and the bottom is the highest in saturated fatty acid, or close. These are animal fats. Some of them at the bottom, like the tuna, has some saturated fat, but it does have more of the polyunsaturated fat in it. So, and a lot of these are less than 50% for this, but just, anyway, it kind of breaks it down a little bit and shows you that animal fats and our tropical oils tend to be higher in saturated fat in our diet. So what about sterols? So, and this is actually from the old book, but I left it in there because I think it's important to visualize that ring-like structure on here. So it's carbon rings, so it looks very different than our fatty acids and triglycerides, and even phospholipids for that matter. This is a precursor for hormone production, which is very important. Cholesterol is a common sterol that we talk about. Cholesterol is important, and we do produce cholesterol. A lot of times we think about cholesterol just from a dietary perspective, But even if we don't eat any cholesterol in our diet, so cholesterol is really found in animal foods, even if we don't eat any of that, so if someone was a vegan, their body would still produce cholesterol. So it is very important for producing some of our steroid hormones, for helping our cell membrane function properly as well. So I think about cholesterol in a bad way, and we'll talk a little bit about the types of cholesterol circulating in your blood and how that could affect your disease risk, etc. But overall, cholesterol is an essential nutrient that, well, so it's not necessarily, sorry, back up. We don't have to necessarily consume it, so it's not an essential nutrient from that definition, but it is an essential compound in our body that our body will make because we do need that in our body. So it is a lipid that our body will utilize for important functions. So it's not something to be afraid of, and we'll talk a little bit more about that. So phospholipids then is our final class of lipids that we're going to look at. And so you may have seen this if you can think back to biology class. This is a cell membrane, and we call this sometimes the phospholipid bilayer. You have two kind of rows of phospholipids with the water-soluble head. So this is our phosphate group on the outside, and that is kind of, we call that hydrophilic. So it's water loving, so it likes water. So it can be more towards the water on the outside of the cell or the inside of the cell. And then the fatty acid tails are hydrophobic or water hating on that. And so they form this layer in here. And so that allows, you see there's other different cholesterol molecules like we just talked about that are very important in the cell wall as well. And this allows them to control what goes in and out of the cells. We do have some examples of phospholipids like lecithin. You can see egg yolks, liver, some plants. Then this may be added to food as an emulsifier to help that our food products be more stable. Sometimes salad dressings will have emulsifiers in them to keep it from separating. Like you may see in this wine glass here that it's showing you, water and fat droplets in there, and you can do this at home on your own. Take a little water, put a little oil in it, watch what happens. And like dish soap is a good way to experiment with this, because then you can see that acts as an emulsifier. That's what helps our water and our greasy stains mix. And so try that. Put water and oil in a glass, watch it separate, because it will, and add some dish soap and kind of stir it up and watch those droplets get smaller and more suspended within the solution. So how do we digest lipids? And lipids are a little bit more complicated than our protein and our carbohydrate digestion, mostly because of what we just talked about in terms of that hydrophobic nature. And so we need that emulsification process that allows the lipids to form stable mixtures with water to help that digestion happen. We do have bile. That's what acts as our emulsifier, and if you remember from the digestion chapter, bile is made in the liver, stored and released from the gallbladder. It is very important for lipid digestion. We also have lipases, which are mainly in the small intestine, that are important for fat digestion as well. And then this thing called micelles are formed, and I'll show you what that looks like, so lipids can be absorbed. So let's talk about this. How does bile and emulsification affect the digestion of lipids? So in this visual, we've got the yellow blob that is representing our lipids, and these green things are our bile acid. There's a fat-soluble and water-soluble side of bile. And so what bile does is kind of attach around these lipid molecules. It then suspends it in water and made into smaller droplets surrounded by the bile acids. We have some pancreatic lipase, so that again, those lipases we talked about that really start breaking down the triglycerides to monoglycerides and free fatty acids. So you can see, it's kind of hard to see in this little first droplet, but they're showing you triglycerides with the 3 fatty acids and the glycerol. And they're breaking it down in here into monoglycerides, so glycerol attached to 1 fatty acid, and then the free fatty acids as well. These are then packaged into the micelles, which I talked about, which just allows it to be packaged in a way that's easily absorbed into our microvilli. So you can see it then will be absorbed through the mucosal cell. They then break apart from the micelle and are absorbed into the transporters and repackaged into these things called chylomicrons. And we'll talk about lipoproteins and chylomicrons, but these then pass through the lymphatic system. So some of the biggest things that make this different from our protein and carbohydrate digestion is the need for this bile, this emulsification process to happen, and then where it goes in the end, which is instead of going directly into the portal vein or our bloodstream, it goes through the lymphatic system since it is fat-based. So those are the key differences in the digestion of lipids compared to our other nutrients. So those lipoproteins, which chylomicron is an example of, are particles that have proteins, phospholipids, and they transport our lipids in the lymphatic system and blood. And so those very large ones from digestion that transport it away from the small intestine are our chylomicrons. We then have very low density lipoproteins and low density lipoproteins, which are primarily responsible for transporting things to the tissues, so to the adipose and skeletal muscles. VLDL is primarily triglycerides, LDL is primarily transporting cholesterol. And then our high density lipoprotein is responsible for transporting cholesterol away from the tissues back to the liver. And you may have heard of some of these, specifically the last two. So if you've heard about getting a cholesterol reading from the doctor, you may see on that report your total cholesterol, but you also may see your LDL cholesterol and your HDL cholesterol. And so those are both readings, and we do look at that in terms of cholesterol ratio when looking at disease risk. It's thought to be really great to have higher HDL, and we want to keep the LDL within a certain range. So depending on what that ratio is, it's some will argue more important than even the total amount of cholesterol in the blood. This is a visual of those lipoproteins. So this chylomicron, you can see it's much larger. This is just one little piece of it because it is so much larger than these other ones that it wouldn't fit in this diagram. And the bottom then will show you the proportion of triglycerides to cholesterol in there. And you can see as they move on, there's more cholesterol proportion. And it just goes over the same functions that we just talked about. So again, VLDL carries mainly triglycerides from liver to muscle and tissue. VLDL then throughout the process is made into LDL, which primarily carries cholesterol to the cells in the body. And then HDL kind of takes the extra cholesterol from the body cells and returns it to the liver. This breaks this down a little bit further if you want to look at that. So this is talking about chylomicrons. So from the small intestine, those lipids are absorbed via the lymphatic system, then to the blood. The chylomicron can deposit these triglycerides, fatty acids to the tissues, remnants taken up by the liver. Our VLDL then produced in the liver and transports mainly triglycerides. As those are broken down and distributed, it kind of becomes LDL, which has just a higher percentage of cholesterol and can deposit that to the body. And then finally, the HDL from there is a little bit of that in the small intestine and then the liver as well, which then picks up the excess cholesterol from the cells and returns it to the liver, where it can be used to make bile acids or excreted. So I know that's kind of the most complicated part that we've talked about so far today. Read through it in your book. I think this is one, if you look through it a couple times, it'll start to make a little bit more sense. But it just shows you how complex even just this one part of our body's system is. So I want to talk about essential fatty acids. And you may have heard of omega-3, but both omega-3 and omega-6 are considered essential fatty acids. And what that means is our body cannot make them. So your body has lots of different links of of fatty acids that it can make that have different functions, but omega-3 and omega-6 cannot be synthesized by the body, so we need to consume them through our diet. So the difference in naming, omega-3 has the first double bond at the third carbon, whereas omega-6 has the first double bond at the sixth carbon. And what's the difference in these? So omega-3 decreases the risk of cardiovascular disease, and we'll talk some more functions on that as well. Omega-6 is important for normal growth. So the names are very similar too. So this linolenic acid is omega-3, and the Linoleic acid is omega-6, so obviously they're one letter apart, so that's easy to get those confused. So I will normally refer to them as omega-3 and omega-6, so don't feel like you have to worry about that too much because I know it's just one letter off and confusing, but that's what they are when you see that, so if that's helpful as well. Our linolenic acid, so omega-3, will produce EPA and DHA, which we don't really efficiently make it from linoleic, but these are some things that are important, and we can get a higher percentage of EPA and DHA in our diet from eating fatty fish in general. And then arachidonic acid is the eicosanoid that can be made from linoleic acid, or omega-6. So again, the functions of these, I apologize. So they produce those, I said that word eicosanoid, these are hormone-like compounds that have different effects. So they regulate blood pressure, inflammation, pain, and the effect depends on the fatty acid. So the eicosanoids from arachidonic acid or omega-6 can increase inflammation and increase blood clotting. And that word inflammation is something that's thrown around a lot these days, and it's typically thrown around in a bad way. And while we're learning more and more about the effects that chronic inflammation may have on disease risk, and things like that, so it's not necessarily something we want in our body. Inflammation in and of itself is not necessarily a bad thing, especially in times of healing or growth. It's essential for growth. It's essential for, healing and wound healing when we have a cut, things like that. So it is all about the balance of those. And then with omega-3 or the EPA, blood clotting and inflammation will decrease. So again, it's kind of that Goldilocks thing. We want if you get a cut, you want your blood to clot, but you don't want your blood to clot too much and cause blood clots that break off and cause heart attacks and strokes. So it's a balance of those things as well. So that balance of omega-3 to omega-6 is important. Currently, in the American diet, most Americans get more, so like a 10-to-1 ratio of omega-6 to omega-3, so more omega-6 and less omega-3 than would be recommended. And so we do recommend that ratio kind of come closer together. When we look at a Mediterranean type eating pattern, we do see that those individuals consume, a closer ratio. So they probably still consume more omega-6, but a much closer ratio of 6 to 3 than in the typical U.S. diet. So where do we get these essential fatty acids? So this is kind of like that same chart we looked at before with type of fatty acid, but it just breaks down the polyunsaturated further into omega-6 and omega-3. So you can see flaxseed oil is one that definitely has a higher ratio of omega-3 than omega-6. Tuna as well, our salmons, those fatty fish have higher ratio of omega-3. Walnuts have a good proportion of omega-3. They still have a lot of omega-6 in that, but again, that's not bad. Canola oil has a higher proportion of that as well. I think canola oil kind of gets a bad rap for some reason, and it does have more of the monounsaturated, but it has a pretty close ratio of 3 to 6 on that. And then you can see some of our other ones that have very little omega-3 in them, like our coconut oil, butter, ground beef, those kind of things. Even olive oil is not a great source of omega-3 in our diet. So that's why it's important to mix it up, eat a variety of fatty acids in there. But our fatty fish, walnuts, flax, those tend to be really good sources of the omega-3 fatty acids that for most Americans would probably be beneficial if they increased in their diet. So back to trans fats. So again, when there are some of those naturally occurring trans fats, but the biggest source of trans fats in our diet are those that are created by adding hydrogen to liquid vegetable oils to make them more solid. So again, margarine was kind of the first example of that. Hey, butter, if saturated fat's bad and butter's bad, just kind of what was going through the heads back then. Then if we, take vegetable oil and make it more solid, then we can spread it on things. That's better through hydrogenation, so that chemical process where they add the hydrogen molecules to unsaturated fatty acids. And a lot of what we see in our food supply, at least it's starting to go away. We're seeing less and less of it, I think, but That partial hydrogenation is really something to look at. So partially hydrogenated oils, you may see that on food labels. And that's converted some of those unsaturated fatty acids from that cis to trans. And again, they thought this was a beneficial thing, but research has really shown that it has a similar effect, if not a more detrimental effect than large amounts of saturated fat in our diet. And we can find these in baked goods, make things more solid. So some of our packaged baked goods especially, so not necessarily when you're baking at home as much as, our snack cakes and those kind of things. Margarine, frozen pizzas, popcorn, etc. We are seeing more companies and restaurants take these out of the diet. A lot of places have started banning them. Several years ago now, New York City banned trans fats in restaurants that had a certain number of restaurants in the city and things like that. So we're seeing less and less of these in our food supply, but it's still something to watch out for. So you can look for that partial hydrogenated oils in an ingredient list. If you send me a picture of a food label with a partially hydrogenated oil listed in the ingredients, you don't even have to buy it, you can just take a picture at the grocery store, then I'll give you extra credit. So send those away if you see them. I left this slide in here. Your book doesn't talk about it as much anymore, but just because it's something that we used to see, there are some fat substitutes. Olestra is a common one. That's a different configuration. They used to make a bunch of potato chips with Olestra. I'm not sure how easy those are to find anymore. But, when we're not absorbing something well, there's, it has to go somewhere. And so there's a lot of GI problems, interference with absorption of vitamins and things like that. So I don't typically recommend them. I don't really want to put things in there that's going to make my GI system not absorb things as well. But just if you see those, that's what that is. Okay, so what do we do with fat? It used to be back in the 90s where everyone was like, oh, low fat, as much low fat as we can take. And now we know fat's important. Fat's very important for our overall diet. And so the AMDR is recommending about 20 to 35% of calories from fat. Focus more on unsaturated fat, limiting saturated and trans fats, and we'll talk about that a little bit more. There's been some, kind of discussion about saturated fats, and are they as bad as we thought they were, and what about coconut oil, and what about all these other ones, and so you'll have an assignment to kind of look at that a little bit as well. But it is just something that, we typically still, with all the evidence, that's what we think should be, an overall thing. It's not saying never eat saturated fat, just, some people kind of took the evidence before. There were some studies that said maybe saturated fat's not as bad as we thought it would be, and somehow some people translate that into eat as much saturated fat as possible and put a stick of butter in your coffee. So, we don't have evidence to support that, the latter for sure. So, this is kind of the best evidence that we have at this point, and we think increasing omega-3 fatty acids is important. I will let someone pick the ketogenic diet. We don't really talk too much about that in this chapter, but I know that that's a hot topic these days, and so some of you may want to learn more about that. And so when we do our popular diet assignment in a few chapters, if someone wants to pick that and research that more and share that with the class, that's great. So keep that in mind. I want you to, if someone's interested in that and learning more about that, you can pick that one. But that is a hot topic that we see a lot of as well, but it was theoretically developed with a really high fat intake percentage for a therapeutic diet reason, not for overall individuals. So again, we can have that discussion more later as well. This nutrition facts panel also has some things to look at. So again, instead of just looking at total fat, maybe look at, this is looking at the percent of calories from fat, but that's not really something that we're seeing on the new nutrition facts label, but really more looking at the saturated fats and trans fats label on that as well. So, normally this is 0. The FDA doesn't really let people do a lot of that, but we can still, you still see some of that. Okay, so we're going to switch over to the supplement now, which talks about kind of how lipids relate to disease, and this specifically is going to look at cardiovascular disease. So look at some of those statistics. So it is the leading cause of death in the U.S., and we talked about that in an earlier chapter. And this just kind of breaks down some of these 34% of adults in the U.S. have high blood pressure. 31% of all deaths in the U.S. are caused by CVD. You can see even 12% have high blood cholesterol. So this is why we're talking about that in this chapter. One thing that we look at is atherosclerosis. So this is one type of cardiovascular disease that is characterized by those narrowing of arteries. And so you can see this over here, that plaque formation. So if the arteries start to narrow because of plaque building up, so plaques deposits cholesterol, triglycerides, other cell material that can deposit on the wall. And there's several thoughts as to why this is depositing, even some damage to our blood vessels, so even having high blood sugar can potentially make plaque more likely to stick and develop. So there's lots of factors that go into this atherosclerosis and plaque formation. And you can see the early plaque versus advanced plaque, where you maybe start to have some rupture vulnerability, and then that clot formation, which can either travel, which can be dangerous, or block the flow of blood, which can also be dangerous in there. So these increase our risk for heart attack and stroke. So myocardial infarction or heart attack can be damage to heart tissue when these blood vessels get blocked and there's not that blood flow going to the coronary arteries. And then a stroke can be that event when the blood vessels that supply the brain are blocked or damaged as well. So this breaks this down even further, if that's helpful for you. So heart attack, you can see this is even breaking it down in terms of this area of the heart that blood was blocked to, and so that part of the heart tissue was damaged. And same thing with the brain that they're looking at, interruption of blood flow to the brain. And so both of these, the severity can vary, etc. So what are our risk factors for developing these cardiovascular diseases? And so this is in your book, you can look at it. Poor diets, so and that's hard to define, some ways, but really, diets high in saturated trans fats, low in our polyunsaturated fats, vegetables, fruits, whole grains, etc. Can increase the risk. Smoking increases the risk. Excessive alcohol, having other heart-related conditions. So high blood glucose, high blood pressure, high LDL cholesterol and triglycerides definitely increases the risk. Physical inactivity. So it's estimated that individuals who get 150 minutes of moderate to vigorous activity per week reduce the risk of CVD by 30 to 35%. And abdominal or central obesity can also be a risk factor as well. So there's lots of things. There's other unmodifiable risk factors, which I think is important to touch on here. And we could argue the modification of some of these other ones as well. I mean, sometimes people naturally have genetic predispositions to have, maybe more body fat or high blood pressure, etc. So we can look at all of these and how modifiable they are, etc. But some things like age, race, family history, those things can also increase our risk of developing cardiovascular disease. So again, diseases are very multifactorial. I don't like to blame one thing for most things. So it is kind of a complex situation. So again, back to those lipoproteins. So we mentioned that the blood cholesterol, so whether it's total blood cholesterol, and high total blood cholesterol makes someone more likely to have heart disease, but even LDL and triglyceride levels, and then higher HDL, and HDL, sometimes you may hear that as your good cholesterol if they're defining it that way, will decrease your risk for developing heart disease. So this breaks down what the levels are. So with total cholesterol, under 200 is desirable, between 200 and 240 is borderline high, above 240 is considered high. For HDL, this is the one that we want it higher, so over 60 is desirable, 40 to 60 is kind of acceptable, and then under 40 is low, or where we don't want it to be. You can see LDL under 100 is optimal, and then it goes up by that, up to over 190 is really the very high. And then triglycerides under 150 is normal, 150 to 200 borderline high, and then it goes up from there. So, if you've ever had your cholesterol screening done, you can use this to kind of assess where you may be on that. So metabolic syndrome is another thing that they discuss in this part of the book as well, and this is really looking at, sometimes we may have one or more of these symptoms. Maybe you naturally have high blood pressure, maybe you naturally have low levels of HDL, but what's your risk of disease? And so really when we're looking at someone having at least 3 of those following 5 concerns, that may increase the risk of developing some of these diseases. And so that's where, we see this affects about 25% of adults worldwide. And this is something that we want to look at as a way to potentially help kind of guide intervention and diagnosis. If you are pretty healthy, don't have any of these other things, but maybe have low HDL, are we as concerned if you have low HDL and high blood pressure, high triglycerides, and high blood sugar? So it can help us really determine kind of risk factors, etc. Okay, this slide, I'm going to take a minute to go over this because it can be a little bit confusing, but I think it's very fascinating. And so what this is really looking at is what we replace energy with. And so, some of the old kind of low-fat things that happened in the 90s were, saying, all right, fat's bad, let's take all fat out and put more sugar in, and that's not good either. So this kind of looks at what we replace our diet with. And so the first one is talking about if you replace 5% of your energy from saturated fat with monounsaturated fat, you'll see a decreased risk of heart disease in general, so change in coronary artery disease risk. If you replace saturated fat with polyunsaturated fat, you see an even higher decreased risk, so even more of a decreased risk. So adding more polyunsaturated fats decrease it even further. If you replace saturated fat with carbohydrates from whole grains, it decreases even, not as quite as high as the fats, but it does still decrease. If you replace saturated fat with carbs from refined starches and added sugars, it actually slightly increases your risk. So, we don't want to say, all right, I'm going to replace my saturated fat from my diet with a bunch of sugar. We don't think that necessarily is beneficial. And then if we replace carbohydrates from refined starches and added sugars with polyunsaturated fat, we also see a pretty big decrease in risk. So the point of this is that, it matters what we replace things with in our diet. So, when we decrease saturated fat and we replace that, with healthy fats, we see an even better risk than just replacing it with other carbs. So it's not saying lower your total amount of fat. We see a bigger impact when we change the type of fat. And then, same thing with carbs. And so cutting out more of those refined starches, added sugars, and replacing them with, whether it be whole grains or polyunsaturated fat, is beneficial. So just the type of fat and carbohydrate in our diet matters. So it's not just total carb, not just total fat, but the types of fat and the balance in there can make a difference in our risk for heart disease. So overall, our heart protective diet is, the dietary guidelines will say saturated fat less than 10% of calories, trans fats as low as possible. You can see the National Cholesterol Education Program is even a little bit more in depth. But this is kind of an overview of some of these, and I'll show you a slide, but more plant sterols, plant-based diets, nuts, oily cold water fish, whole grain oats, moderate alcohol, unsaturated oils for saturated fats, and this visualizes this a little bit better. So plant-based diets have a lot of our phytochemicals that help reduce blood clotting, help reduce LDL, oxidation. Nut consumption is very important. Whole grains have been shown to be important. The omega-3 fatty acids in fish can be very important. I want to talk about the alcohol really quickly because alcohol is still, even red wine, is still kind of a little bit of a topic depending on what kind of researcher you talk to. So we do see moderate alcohol consumption raises HDL cholesterol and may reduce the risk of cardiovascular disease. And they define moderate as no more than one drink for women and no more than 2 for men per day. But when we go into the next chapter and look at cancer, the cancer community of research will say that all levels of alcohol intake increase your risk of cancer. So it's kind of, maybe decreases risk of heart disease, maybe increases risk of cancer, and so you kind of have to take all of that with a grain of salt a little bit. But, I'm here, I want you guys to see the research. I want you to know kind of where things stand and make decisions for yourself on that. But it is just kind of a caveat that we have to look at when we're looking at nutrition. A lot of times people look at nutrition research from one single perspective, and we can't really make recommendations from one single perspective. We have to look at a lot of studies, a lot of diseases, overall health, and see what we can find. So it is very complicated, but maybe that's why I love it so much. So anyways, hope this was a good overview of fats, cardiovascular disease. This is a good chapter to make sure you're reading through again in the ebook. And let me know if you have any questions or concerns.